All right, for this lesson, we're going to be talking about how to complete the square, and we're going to learn how to complete the square so that we can convert a standard form quadratic equation or function into vertex form. So when we're completing the square, the whole point is that we're trying to make what we call a perfect square trinomial. So a perfect square trinomial happens when I have two of the same binomials being multiplied together. So if I have x plus 5 times x plus 5, if we multiplied that, that's going to be x squared plus 5x plus 5x plus 25. And then, of course, we can combine those together and we get x squared plus 10x plus 25. That is what we call a perfect square trinomial. However, we also are not going to be multiplying this out. What we're going to want to do is we're going to want to take these two parentheses once we are able to get those perfect square, get that perfect square trinomial, and we're going to make it into x plus 5 squared. Okay, so we're going to take the two identical linear binomials and we're going to write them and square it, just like we have done previously when we had that and we expanded it and multiplied it. So we're going to talk about the process of completing the square first, and we're going to set this up so that it's going to be easier to put it in vertex form. You will learn later that there's going to be a rearrangement of the c value in order to solve. So we are going to use this for solving later, but for right now we're going to use this to put this into vertex form. So we are going to write this. So technically, remember, our standard form of a quadratic is ax squared plus bx plus c. Now you may need to rearrange if there's some things that are on the wrong side. You may need to add or subtract those in order to move them over. But what we're going to do this a little bit different this time is we're going to set this up so that it's ax squared plus bx, and we're going to say it's equal to c. So we're going to move that c around so that it's on the right hand side. Now, when I look at this one right here, I already have ax squared plus bx equals c. So we don't need to rearrange this one. It's already in the correct format to get started. All right, for the next step, we're going to be looking at the leading coefficient. So the leading coefficient is the a value. Now, sometimes you're going to have to do this and sometimes you're not, but basically, if you have an a value that's greater than 1, or technically less than 1, something other than 1, we could have a negative in front, you're going to factor out that a value by dividing every term by a. So when I look at this example, I have x squared plus 8x equals -7, and my a value here is a 1. We don't need to divide here because my a value is already equal to 1, so we don't have to do this extra step. So no extra step on this one. Now if it was something other than 1 for the a value, and you'll see some examples further on where we talk about that. So we've identified the a, so we do not need to divide here or factor out the a value. All right, now that we have basically set this up in a formatting that we want to, we're going to use the coefficient of b, and we're going to use a particular division and squaring of that b value in order to create this perfect square trinomial. Now, I will say that when you do this, I always like to put placeholders, because basically what you're going to do is you're going to be making a trinomial on the left-hand side. You're going to make that perfect square trinomial. So I like to put a placeholder, but I have to use that value on both sides. It's just like any equation, you have to keep it balanced. So the first step is to divide the b value by 2. So my b value in this particular example is positive 8. Now, sometimes you may get a value that is odd number. You're still going to have to divide that. So we're going to divide the b value by 2. So my b value is 8. So we're going to say for this particular example, we're going to say that 8 is divided by 2 here. So technically that does equal 4. All right, so we get the b value, or b divided by 2 is equal to 4, okay? So once we divide that by 2, now you're going to square the value that you got. So the b divided by 2 is what's inside. So these two right here are the same. So that would have been 4. But then you're going to square it to make it a perfect square number. So we're going to now take that 4 and we're going to divide that 4, or excuse me, we're going to square that 4 by 2. And once we square that, we're going to get 16. Okay. Now, here's what's important is now that we've got that 16 is going to be the number that you're going to apply to both sides in where we put those placeholders. And the reason that we want to do that is because we now have a perfect square trinomial that was created on this left-hand side. Okay, so once we've done that, we're now going to set that up, and we're going to factor the left-hand side. So on this particular situation, we are going to go ahead and simplify this. So we have x squared plus 8x plus 16, and that's now going to equal -7 plus 16 is +9. So what we're going to want to do is we're now going to want to factor this trinomial. So we're going to factor the trinomial just like we've done before, and we're looking for two values. We need the two values that multiply to give us 16, but add to give us 8. Now, again, this number is still important, but we're focusing on just this trinomial on the left-hand side so we can actually get it into those two identical binomials. So two numbers that multiply to give me 16, but then add to give me 8, that's going to be 4 and 4. And again, those should be the same numbers because that was the whole point of completing the squares. They should have the same value. So this is going to become, so we have x squared plus 8x plus 16 that we had on that side. And this is now going to become x plus 4 times x plus 4. And that's going to equal 9. Now, in doing that, we now have two linear binomials that are the same. And once we have done that, we can put those together and we can say x plus 4 squared equals 9. Now, at this point, this formatting, okay, is actually going to be very helpful in stopping here, okay, when we get to the solving section. Right now, we're just learning how to convert it from standard form into vertex form. So when we think about vertex form, so we're looking at, it says place the factors together and square them, which is what we did. So we said x plus 4, and then we squared it, and we put those together. Now, again, that's going to be this formatting right here. So this formatting that we have is the same one as we have here. That's going to be great for solving later. Okay, so that's going to be useful for solving. However, we want to convert this into vertex form. So we're going to want to put this in vertex form. And if you notice, when we're looking at vertex form, we have this k value, which is going to be the same thing as a c value. But up here, the k is on the right-hand side of the equal sign. We want to get that k, and we're going to move it back over here. Now, also, when the time comes and you are going to be looking at the solving, you need to make sure that you understand that if you have an a in front, which we had a 1, that a is still going to be applied later. And we'll talk about that when we get to solving. But in order to get that k back on the left-hand side, we're just going to add or subtract it back over. So we're going to add or subtract the constant back to the left side. And if you have an a value, you're going to have to multiply that a value back into the entire equation, including the k value, which again, our a value is 1, so that doesn't really apply a whole lot here. So to get this in vertex form, okay, So remember our vertex form, we want that K or that C, we want to move that back to the left-hand side. So we're now going to subtract that over. Okay, so once we subtract that over, I now have x plus 4 squared minus 9 technically equals 0 because that's what's left, but you don't have to set it equal to 0. We're just trying to put it in the vertex form. So at this point, if whatever my a value was, so remember we had an a value of 1, that a would get multiplied back into the entire problem. So multiplying it by 1. Now, multiplying it by 1 doesn't change anything, but you got to remember that we're going to multiply the 1 to the parentheses because we can't multiply it in the parentheses because it's squared. We're going to multiply the 1 to the parentheses, and it gets multiplied to the negative 9, so that's going to be important later. So my final vertex form for this problem is going to be the x plus 4 squared minus 9. And you can always put a y equals in front of it if you want it to make it into a function. But then you can actually tell me what the vertex form is, or tell me what the vertex is. You could tell me that the vertex of the parabola is located at the h and the k. So remember my h is the number being added or subtracted in the parentheses, and this is my k. So we're going to do the opposite of the h is negative 4, and my k is negative 9. So there's a lot of things that we can use the completing the square process for, and again, we'll be using it and rearranging it a little bit more later. But for right now, we're just using this to put it into vertex form. So we're going to look at a few more examples. So looking at this one, I don't have this set equal to 0. All I have is y equals, this is in standard form. I want to take this standard form and I want to put this into vertex form. So in our first step, we need to get this in the format that says that our C value is on the other side. So if it's equal to 0 or it's equal to y like this, what I would go ahead and do is I would just set it up to look similar to the first problem that I gave you and set it equal to 0 and just kind of take that y away for right now. So we're going to take this 9 and we're going to move it over because we want that to be on the other side. We want to set it up so the C value is on the other side. So I have negative 3x squared minus 18, and it now equals positive 9. Now, this is where we need to apply our a value. So we know that our a value is a negative 3. So before we can complete the square, we need to factor that a value out, and we need to divide every piece by the a value. So we're going to divide every term. So we're going to divide that by negative 3. We're going to divide this one by negative 3, and we're going to divide the 9 by negative 3. Now, if you want to do that in this step up here first before you move everything over, that's fine. It doesn't matter which one you do first, the moving or the dividing, as long as you do both. Now, at this point, we're going to be left with 1x squared. Okay, so we're going to have just x squared here. Negative 18 divided by negative 3 is going to be positive 6x. Now, eventually what we're going to have to do is we are going to be completing the square, just like we did previously. So I'm going to go ahead and put my placeholders here. And then negative 9 divided by negative 3, or 9 divided by negative 3 is going to be negative 3. And don't forget the placeholder on this side. Okay? So we're halfway to completing the square here. So at this point, I now have it set up. I'm going to complete the square. Because remember, the whole point of completing the square is to get that perfect square trinomial so it's in that vertex form that we're looking for. So we're going to start by looking at what our b value is. So our b value right now is 6. So we're going to use the formula and we're going to say that b divided by 2. Okay, so remember our formula here is b divided by 2, and then we're going to square it. Okay, that's what's going to go in those spots. So if we divide this, that's going to be 6 divided by 2. And if I take the 6 divided by 2, we know that that's going to be 3. So we have 3 squared, which is going to give me a value of 9. So we're going to input that 9, and we're going to put it here and here. So we have 9 and 9. And again, the whole reason and the whole point of this is because now we have a perfect square trinomial that we can factor. So all of this together, we have x squared plus 6x plus 9, and we're going to simplify this, and we're going to combine -3 and 9, which is going to give me +6. So we're going to focus on our perfect square trinomial now, and we're going to try to find two numbers. And those two numbers need to multiply to give me 9, but add to give me 6. And again, they should be the same, so it's 3 and 3. Now, the other thing you're going to recognize is once you start doing this over and over, you should be able to recognize that this number, when you divide 6 and 2, that's going to give you the number of the factors. So whatever number you get before you square it, that's actually going to be the two identical factors. So we're going to have x plus 3 times x plus 3 equals 6, and that's where we can square those. So we're going to square those pieces now, and we now have x plus 3 squared equals 6. Now, the only other additional steps is reformatting and applying that a value back in our problem that we had before. So the last thing is we want to move, so if I go back to my step, we want to get that k value that we have on the right hand side, we want to get it back to the left hand side. So I'm going to move it back over. I'm going to subtract that over. So I now have x plus 3 squared minus 6, and we can set it equal to 0 just so it kind of keeps you mindful of what's the left and the right. And then finally, the last step is to multiply the a value back into the entire problem. Okay? Now, in doing this, what's going to happen is that -3 is going to go in front of the parentheses, and that -3 has to be multiplied by that -6. So my final vertex form is going to be -3. Just leave it right outside the parentheses because it's squared. We're not multiplying it in. And then -3 times -6 is going to be +18. And again, you can set it equal to 0, or you can go ahead and say, okay, at this point, I know that the original formatting was y equals to make it a function. So I have my vertex form. This is x minus h, because it's technically the opposite, squared plus k. And then you could tell me anything you needed to tell me based off the vertex form. Okay? So my final vertex form in this problem is this one right here. Now, if you ever want to see if you got this correct, you can always go to Desmos, and in Desmos you can put in your original problem. So we have y equals -3x squared minus 18x minus 9. That's my first one, or that's my original and standard form. Then we got vertex form is -3 parentheses x plus 3 squared plus 18. And you should see that they graph match each other because they are equivalent. They're just in different formats. They're the same graph. All right, so looking at my next one. So my next one, I do have an a value, and that a value is a +8, okay? And with that +8, that means that we're going to go ahead, I'm going to divide it out this time. Like last time I told you that I could move it and then divide it. This time I'm going to divide it and then move it. Again, it doesn't matter. So if I have a equal 8, that means we're going to divide each term by 8. So I'm going to go ahead and set this up. and I have x squared. That's going to be minus 2x. And then that's going to be 9 divided by 8. And of course, 9 divided by 8, that's not going to simplify nicely. So we're just going to leave it as 9 over 8. That's okay. That's kind of the point of completing the squares. Sometimes you need to make it into a nice trinomial because you don't have numbers that are factorable to begin with. All right, and I'm going to go ahead and set that equal to 0. So I'm going to move this over now because remember that's kind of that is the formatting. We need to move that 8 over, that 9 over 8 over for the k. All right, so we have x squared minus 2x. Again, I'm going to put my placeholders now because I've moved that over to create that perfect trinomial in order to get that identical linear binomials. And I'm going to make sure I apply that to both sides. So we want to set this up. So we're going to say the b value, now that minus in front is going to make the b a negative 2. So if b is equal to negative 2, we're going to be saying b divided by 2. And then after we divide that by 2, we're going to square it. So we're going to say negative 2 divided by 2 and then square. And again, that's going to be negative 2 divided by 2 is negative 1 squared, which is going to equal positive 1. So the number that's going to make this a perfect square trinomial is positive 1. Now that 1 is going to go into those placeholders that we just did because that's going to be that perfect square trinomial on the left-hand side. So we now have x squared minus 2x plus 1, and that's going to equal negative 9 divided by 8. If you need to use the calculator to calculate that, that's fine. So negative 9 divided by 8 plus 1. And of course, I would probably turn it back into a fraction. It's up to you though. And I get negative 1 over 8. All right, so from there, we're going to keep going with the process. So the whole point is that this perfect square trinomial that we just found is what we want to factor. So I need 2 factors, and it should be, remember I said it should be the number that you got before you squared the b over 2. So we need a positive 1 that's being multiplied, but then it's going to add to give me negative 2, which is in fact going to be negative 1 times negative 1. So this is going to be x minus 1 times x minus 1, and that equals negative 1 over 8, which is going to then be combined together to be x minus 1 squared equals negative 8. And then we want to get it into vertex form. You eventually, like I said multiple times before now, when we go to solve, we're going to be solving this and we're going to want to leave that k value on the other side, but we want to put it in vertex form. So we're going to add that 1 over 8 back to the left side. So we now have x minus 1 squared plus 1 over 8 equals 0. Now, once we've done everything, I know it's quite a bit of rearranging and all that, but I promise you it's for the best. There are other methods that'll teach you to leave it on that side, but then the students wind up mixing the signs up more than they get it correct. So I always recommend moving it first and then moving it back later. So to finalize this, we are now going to apply that a value back into the problem. So we're going to take the entire problem and we're going to multiply it by 8. So this is going to go in front of the parentheses, and then we've got to multiply it by the 1/8, and of course the 0 is going to stay the same. So my final vertex form is 8 times x minus 1 squared, and then 8 times 1 over 8 is just going to equal positive 1. And we now have our final vertex form. We have our a, we know our h is a positive 1, our k is also going to be positive 1. And just like I did previously, I can absolutely check that in Desmo. So I have 8x squared minus 16x. I believe it was plus 9. Yes. And then I had my vertex form was 8 times x minus 1 squared plus 1. And I can see that those graph match and they are identical. All right, so for this one right here, we have x squared equals 10x plus 41. So I'm going to set this up. I have an a value of 1, so I do not need to divide first here. So I can actually go ahead and start rearranging this problem. I do not have to divide that value out, and I do not have to worry about multiplying it back in at the end. So we're going to move that over. And again, there are methods that do pretty much the same thing, but they teach you to keep the C value on the same side, but it requires you to recognize opposite signs and applying that all the way through and remembering to apply that all the way through. And a lot of times students make that mistake and mix it up. So we're going to do x squared plus 10x, and we're going to put our placeholder. And now that we subtracted that, that's going to be negative 41. And we're going to apply our b divided by 2 and then squaring it. All right, so my b divided by 2 is 10 divided by 2 and then squared. So 10 divided by 2 is 5. And then 5 squared is going to be 25. So that 25 is what's going to go into our placeholders that we're applying to both sides. All right. And that leaves us with x squared plus 10x plus 25. And we now have negative 41, and that's going to be negative 41 plus 25. And that's going to give me negative 16. So we're going to factor this perfect trinomial that we completed the square for. So we need two numbers that are going to multiply to give me 25. But then you're going to add to give me 10. And again, those two numbers should match the number that you got after you did the b divided by 2, which is 5. So 5 times 5 is 25. 5 plus 5 is 10. So I have x plus 5 times x plus 5. And that's going to equal negative 16. And at this point, we can put it into the squared version, so x plus 5 squared. And I'm going to go ahead, and now that I've done the squared version, I'm going to go ahead and move that 16 back over. And that's going to give me plus 16. And again, the a value was 1, so we do not need to multiply the 1 back in. So my vertex form for this one is x plus 5 squared plus 16. All right, one thing I did want to add on, and this is not on the notes handout, but what happens if I'm completing the square and the b is odd? Because essentially we're dividing it by 2, so we have an odd value. We don't normally use that unless we're actually trying to solve, but I did want to show you a version and what it would look like. So my a value here, I have an a value that's equal to 2, so I'm going to divide each piece by 2. And again, you can move your c over first and then divide, or divide and then move the c over. It's completely up to you which process you want to do first. So I have x squared minus 5x, because negative 10 divided by 2 is negative 5x, minus 24. We're going to set that equal to 0. So I'm going to now move the c over, so I'm going to add the 24. All right, and I'm left with x squared minus 5x. I'm going to go ahead and put my placeholders where I know I'm going to be completing the square. And I am going to set it up, and I'm going to do my b divided by 2 and then squared. So my b in this problem is negative 5. So we're going to do negative 5 divided by 2, and then we're going to square that. So negative 5 divided by 2 is going to stay negative 5 over 2, or you can make it negative 2.5 if you want to, but we're going to try to maintain fractions when we do these just because it makes sure that we don't have to worry about rounding. So once I square that, I get a value of positive 25 over 4. That number, even though it's a fraction, is still going to go into the parentheses, or going to go in the placeholder. Okay, now here's where you got to think about what we did previously. I have x squared minus 5x plus 25 over 4, or you can do it as a decimal as long as you don't have to worry about rounding. And then we have 24 plus 25 over 4, and we can leave that as 30.25 or make it 121 over 4. Now, technically we should be factoring this, but I don't think that we're not in a position to factor and figure out what numbers multiply to give us 25 over 4 and then add to give us negative 5. So this is where I like to think about my patterns that I've had previously. And remember, I told you that the pattern is the number that was was the b divided by 2, right? So technically when we go to factor, every time that we have factored, we had the value x plus or minus depending on whatever. So we had this was the b divided by 2 on both sides, whatever value that was when we completed the square. So I know that this is going to be x minus 5 over 2, and then x minus 5 over 2, and that equals 121 over 4. So I get that there's a lot of fractions happening here, but the process is still the same. You just got to make sure you correctly apply everything. And I'm going to go ahead and move that back over. I'm going to subtract that 121 over 4 to get it in vertex form. And again, this vertex form is not going to be the best just because it is a fraction, but I mean, if you had to do it, it's not impossible. So I have x minus 5 over 2, that's going to be squared, minus 121 over 4. And at this point, that's going to equal 0, but we've got to remember to go back and apply, and we've got to multiply all of that by the a value, and that a value was 2. So I'm going to have 2 in front, and that's going to be x minus 5 over 2 squared. And that a value also is going to get multiplied to the negative 121 over 4. So when we go to look at that, you can put it into Desmos and calculate that. But basically what we're going to have is 121 divided by 2. And we now have our vertex form. And again, at this point, I could determine that the vertex is located of the parabola, and it's going to be located at 5 over 2 for the h, and negative 121 over 2 for the k. Now, they're both being divided by 2. Those are going to round into decimals that I can look at. But if I go to Desmos and I put this in, because especially when you have problems like this, it's not hard to question yourself of whether you got it right or not. Alright, so there's my original. So if I look at that vertex right there, I got 2.5 and negative 60.5. So remember, we had 5 over 2, that's 2.5, negative 121 divided by 2, and that's negative 60.5. So that is, in fact, our vertex. So if I come here and put the format that we had, so we had 2 times x minus 5 over 2, squared, and then minus 121 divided by 2, that does graph match. So if you do have odd b values, It's not ideal, but it's also the same process. You just got to worry about making sure you calculate your fractions correctly. So now let's actually talk about the key features when we have vertex form. So a quadratic function can be written in different formats, which we've already seen. So we have vertex form, and it's called vertex form because you can easily find the vertex and the axis of symmetry, because remember the axis of symmetry goes through the vertex. So when we look at our problem, so when we are talking about the A, the H, and the K, these are important because the A value is going to tell me, just like it has previously, if A is negative, okay, so if A is negative, then it opens downward, and then if A is positive, then it's going to open upward. And that's going to be important because that's also going to help me with the range. So remember, if it opens downward, it goes like this, which means I have a maximum. If it opens upward, it goes like this, which means I have a minimum. So that's also going to be important because we can determine the vertex using this form. And if we know the vertex, that means we know the maximum and the minimum as well. So the H and the K. So the H and the K represent the values of the vertex. So the H is the X value. However, it has to be the opposite value. So the typical formula for this is going to be X minus H. So when we substitute the H in, it's always the opposite. Now, that means that my vertex is going to be the H value and the K value. Now, the K value is standing alone, so you always take the K value as is. And that is also going to be something you need to remember for when we get to transformations, because we're going to be using those values as well. So the H is the X value, which means that the axis of symmetry, so the H is the X value of the vertex, and then the axis of symmetry is also going to be the H value. So whatever the H value is in the vertex form, that's where the axis of symmetry is. And just don't forget that the H is always the opposite of what it is in the equation. And then finally, we have the K value. So the K value is the Y value of the vertex. So that's that number being added or subtracted on the outside, and you take that at face value. All right, so some characteristics to kind of talk about. So when we talked about quadratics previously, the domain is always all real x's. The quadratics are never going to have any x values that are not included. The range, however, is different. And the reason that is because if A is positive, that means it opens upward. So remember, if it opens upward, that means I have a minimum value. And the minimum value is the Y value or the K value. So that means that the range is the Y value, is going to start from that and go up. So since it's going up, that means the Y's are greater than or equal to the K value. Then if the A is negative, that means that it's going to open downward, which means I have a maximum value. And the maximum value is also going to be that same K value because it's the Y value of the vertex. So that means that it's opening down. So that means everything is less than that K value. So that means all the range is all Y values that are less than or equal to K. So you can always graph these if you're able to in Desmos. But we can also look at vertex form and determine some things. So when I'm looking at this, I have an A value that's 1. So that means that it's positive. And since it's positive, that means that it's going to open upward. My H value, so remember it's the opposite. So in the equation, the subtraction is always the standard form of the equation. So my H is going to be positive 1 and my K is going to be 2. So since it's positive, it is opening upward. And that means that my vertex point is going to be a minimum. So my vertex is located at 1, 2. So my vertex is a minimum. So my axis of symmetry is always the H value, which is 1. So it's going to look something similar to this. So there's my quadratic. So there's my vertex. It's located at 1, 2. and then it's going to be going through that vertex, which is our axis of symmetry, and that axis of symmetry is located at x equals 1. So again, the domain is always going to be all real x values. So then we need to talk about the range. So since we're starting at the bottom, that means that it's a minimum and we're going to be going up. Now, my k value is how we're going to apply that range over here. So remember that k value is that minimum value, and it's going up, so my y values are greater than or equal to 2. All right, so for this one, I have a value of -3, so that's a negative value, so that's going to be important because it's going to open downward. And if it opens downward, that means that I'm going to have a maximum this time. So it's going to look something similar to that. So we're going to have a max up here. So my h, this time my h is positive, so when we take it out, it's going to be the opposite, so it's going to be negative because the original format would have been negative. So how is it the opposite? So this technically should be x minus, and then to make it a positive, it would have been a -4. So minus a negative would have made it positive. All right, and then my k value is -5. So that means my vertex is located at -4, -5, and my axis of symmetry is that h value as well, which is x equals -4. Again, my domain is all real x values. And then we need to talk about the range. So this one's a little bit different because my point up here is my max point again. So remember that point was -4, -5. And we're going to apply the range because the max value is -5. So everything is going to be less than that because it's opening downward. So my y values are less than or equal to -5. All right, so for this one, I have -4 as my a. So that means that it's got a negative a value, which means it's going to open downward again. Okay, so if it opens downward, that means I'm going to have a maximum. So my h is the opposite, so it was -8, so we're going to make it +8. And then my k, so right now I don't see a k, so technically it's +0. So I have to have a k value. So if I don't see one, it's automatically 0 because there's no number there, which means +0 is not going to change anything. So my vertex is located at 8, 0. So again, something similar to this, and it's going to be located at a max point of 8, 0. So my axis of symmetry is x equals 8, because it's the h value. The domain, always for a quadratic, is all real x values. So then we need to talk about the actual range here. So the range is my y values. And if we're looking at those y values, we're talking about how far is it going up or down. So that's going to be restricted by my k value. So my max k value as 0 right here, and then it's going downward. So my range here is going to be y is less than or equal to 0. Let me know if you have any questions.